Hey, this is Math 2 Unit 4, worksheet number 3, looking at angle bisectors today. So angle bisectors are lines that are going to take an angle and we're going to chop it up. We're going to bisect it into generally two equal parts there. Okay? So we're going to draw a bisector first of all of angle A. That means we're going to have a line that goes right through that there, something like this. Just cuts it straight across. And that means that this angle is going to make this the same distance as that angle there. They're going to be matching, and we can mark that there like so to show that those are congruent angles, like that one. Okay? When I look at 2, it says draw the perpendicular bisector of DF. So that means we're looking at a line that's going to cut this in half. So we're going to go halfway between these 2 points, right? Somewhere about here, for example. And that means there's going to be a line that was to go straight up 90-degree angle from there. So make my line there like so, and it cuts it like that, and that makes these 2 lines equal, and that's a perpendicular bisector. So an angle bisector gives me 2 angles that are the same length on the side of that line there, and a perpendicular bisector gives me 2 segments that are the same length. So keep those 2 things in mind for what they do. Okay? If a point is on the bisector of an angle, so if a point is on this line, on that line, then the point is equidistant from the side of the angle. Meaning that if I have a point on this line, let's say this one right here, okay, it's going to be the same distance from here to here it is there to there. Doesn't look very good in my picture, but that's going to be the same distance there is the idea. Okay, let's move down here. Number 4. It says find the value of x. So because of what we just said, this length is the same distance away from here as this length is. There's an angle bisector, and this point is the same distance away from these 2 lines. So we can say that 3x is going to be equal to 12, and that's what we just said up here. So to find x, we divide both sides by 3, and x equals 4. Okay? We can see the angles are equal. It's an angle bisector. Over here, we have angles there. We see these are equal distance because we see these are equal distance. That tells us these angles will be the same. So 4x is going to equal 2x plus 20. Subtract 2x from both sides, and we get 2x equal to 20. Divide by 2. And x is equal to 10. Alright, so that's what we're looking at there. Again, these are 2 ways of looking at really the same thing. The angle bisector shows us that these lengths will be the same, and a perpendicular bisector shows us that the segments will be the same. So in this case, when the segments are the same here, it tells us we have an angle bisector there. So those equal one another. Okay? We're using that same idea down below to look at number 6 and 7. I'll look at just one of these here to start with. So for number 6, we know that we have an angle bisector, so this equals that. Because this is an angle bisector, then this length here is equal to this length here. So we would set them equal to each other. 5x minus 3 equals 3x plus 1. I'm going to subtract 3x from both sides, so I have 2x over here. I'm going to add 3 to both sides, and I have 3 plus 1 is 4. Divide both sides by 2, and x equals 2. So we're in good shape there. Now to find the length of BA, I plug 2 into it. 5 times 2 is 10, minus 3 is 7. I could do the math for the other one, but I've already said they're equal, so I know it's also going to be 7. Okay, looking at number 7. Here we have angle bisectors, which means these angles are going to be equal to each other. So we set them equal. 3x plus 12 equals 5x. Let's subtract 3x, subtract 3x, and we're left with 12 equals 2x. Divide both sides by 2, and 6 equals x. So we got that there. To find out what the angle measurements are, we plug that value in. 3 times 6 is 18. 18 plus 12 is 30. So we have 30 degrees, and because they're equal, that one's 30 degrees as well. Okay, you're going to use those same principles there to help you solve this last part here on this front page, 8 through 13. It's the same idea, we have lengths that are going to be the same here and here, angle measurements the same here and here, and knowing that, you can then solve for the other missing pieces within that triangle, because the whole sum of the angles of the triangle should equal 180 degrees, and that'll help you find out what's missing in there as well. I'm going to turn the page over and look at the back side to help out with some questions on the back side of your homework for tonight. On the back side, we begin with this triangle here, or a little angle bisector, and it says, is A, this point here, on the angle bisector of XYZ? And it really wants you to explain this in your words. The answer is going to be yes, and I'm not going to write anything else down. I'm going to say yes, and here's why it's a yes. The reason it's yes is because it is equidistant, right? That's your key word, equidistant, right? From here and from here. It's equidistant from XY and YZ. It's the same distance away from those lines. We see that by this little line right there. That tells us it's the same distance. Because it's equidistant, this point is on the angle bisector. That is my angle bisector right there. That's my angle bisector. This line is my angle bisector. And that's why we would say yes. Okay? Down below, let's take a look at these guys here. This is probably more review from the class. Looking at this shape here, this point of concurrency where they all come together, because we're looking at segment bisectors, right? These are segment bisectors. Where the segment bisectors come together, we call that the circumcenter, okay, where it comes together. And this becomes the center of a circumscribed circle, meaning that if I take these things out this way, and I draw a circle, I should be able to get a circle, that's my center point, around this triangle where that is the middle. And if I took a little like compass tool, I could draw a circle perfectly around that and make that the middle. Okay? And you maybe did that in class, not sure how much you did there. I'm just sketching it there to get you going. This one though is a little different because instead of using the segment bisectors, we use angle bisectors. And the angle bisectors come together in the middle. We call that point there, that is called the incenter. And let's kind of think of it this way. It's in the middle, right? And we're using, of course, that one's in the middle too, but we know our lines extend out that way too. Okay? So the circumcenter is when we're looking for the segment bisectors, and incenters with the angle bisectors. This is the center of the inscribed circle, right? Circumscribed goes here. Inscribed means that that's the center of a circle that's on the inside of that triangle, and that's the middle point of that circle. That's the idea there. Okay, that's it for today. Hope that helps you out with your homework. Again, if you have more questions, check with your teacher as always. Have a good day.